Fuck me. That doesn't matter what to do. come on! Jesus fucking Christ. It's alright. So everyone has a Peter 2, right? You know what? We need to do the other half. Hello. How you doing? Give me 1 second. I am trying to mount a piece here so I can pilot drill it once it's mounted. And it is a pain. How's your night going? We're trying to get a certain spacing here from the end of this piece and also from the bottom edge, so it's a little interesting to say the least. All right, let's continue this. Hey. How you doing, streamer trash? I will hydrate for you. There you go, hydrated. Thanks for the reminder. How you doing, streamer trash? Let's change I'm gonna change our camera here to give us a better view of what we're actually working on. Hey, can you guys see the workshop from there? Not quite. I've got another camera that might be a little bit better. Let's try this. That camera there. Sorry. I think that's a little bit better. Not ideal, but it's a little bit better. You can kind of see what I'm doing over there. See? Yeah. Let me move this chair out of the way. Well, this is holding tools, so can't move it too much out of the way. Oh, what? Come on. Come on, pups. Come. Oh. So, anyway, streamer trash. That's kind of where we're at. We're trying to place this piece here, but we've got to maintain a certain amount of edge spacing. So we're using a straight edge that we have that has the right distance to basically set our straight edge. And then we're doing our part here to then we'll double check this once it's done, but we got to put a bunch of clamps in, so don't mind me. Chloe, yeah? Chloe, stop. Hey! Oh, dog's gonna be the death of me, chat. Hey, what did I tell you? Stop. All right. All right. We've got our piece placed. So we need a 1/16 of an inch spacing from the edge of that piece. So in the plans, we need a 1/16 of an inch spacing. Our straight edge is about a 1/16 of an inch. So we're using the straight edge to basically mount that piece so then we can pilot drill it. So now we can take our whole giant piece that's attached and move this whole piece to a place where we can potentially drill it, which is over here. All right, so yeah, like I said, we had to do a whole bunch of nonsense, and now we're in a place where we can better position to potentially drill this now that that hinge is mounted. We gotta check some clearances and stuff, but yes, yeah. See, that's not gonna work because I feel like we're flush there. You need a 1/16 of an inch. On this side, we have a 1/16. What about on the other side? I don't know if we have a 1/16 on the other side. On the other side, it does not look like we have a 1/16 of an inch. It looks like that shifted, so that's kind of the problem we've been dealing with, is we need a 1/16 of an inch clearance. And this side has it. This side over here definitely does not. Yeah, I feel like this side shifted or something. This side over here definitely doesn't have that 1/16 of an inch clearance. Let's see if it does now. It looks like it does now. We moved a piece, but that concerns me. We're probably going to want to drill that with that straight edge there the entire time, just to make it better. The biggest problem I have is that this whole flap isn't. I feel like it's not completely square, and that scares me. It's got a little bit of a twist in it. I feel like that right there is straight. It feels like it's got some twist. That hole lines up pretty good with what we want. This one's a little bit off. This one's a little bit off. This one's a little bit off, but that's because of, like I said, because I think it has a twist. If we do this, eliminate that twist, these holes line up much better. They're not perfect, but they're better. Yeah, I think that's where we need these things to be. All right, I think we are good to drill now, chat. We're gonna place this on the ground again and double check it with the straight edge to make sure we have the right clearance, but I think we're good to drill now with the new position we have for it. It's over here, and I should be able to slide this in with just enough clearance. Right? Yep, that guy slides in just right. It's a little bit tighter on this side, so I think we're gonna redo this side over here. We're gonna redo this side over here because I don't feel happy with where it's at. Right? That guy should fit in there. No problem. With that spacing so that this guy can slide in and out. That'll give us our 1/16 spacing. Over here, should have similar spacing. Yeah, I don't like this guy either over here, so we're gonna do this guy over here. Okay. Slides in. He slides in. Slides in and hits a lip. Slides in and hits a lip. Okay, that one's good. Now we're gonna slide to the other end and recheck this side over here. Should have the same clearance. Yeah. There we go. All right. Let's try that again. Over here. Yeah, we clearly hit the lip. Clearly hit our lip. Clearly hit our lip. And that's what we want. We're looking for a 16th spacing, and I think we've got it now. That looks like a 16th. And that looks like a 16th. So I think we're good now. I think we're good now. So now that we're good, we can set the It extends down. It doesn't. So it's got a hinge. It's got a hinge here, and then that hinge. Let me switch. That's wrong. It's got a hinge down here that you can't see, and basically it rotates down, so the top separates from the wing as it comes down, separating the air. You know, mostly adding drag. It adds some lift, but mostly adds drag. So it does not rotate down. It just angles down off of a hinge. But I'm just making sure I have the proper edge clearance so that it will rotate around the edge. I need a 1/16 of an inch, and it feels like I've got that, so I think we're in a good spot. I think we're in a good spot. So we're gonna drill the 4 holes to so that we have the pilot holes we need to attach the rib, basically. And then we'll go back and we'll drill the entire hinge, but we're gonna start with the pilot holes we need. So. All right. Now that that's done, we can. I can basically remove the whole hinge, and I'll show you how the flap extends. Because we don't need that hinge there now. Oh. So yeah. So here you go. Here's your piano hinge. The flap hooks up to one side, the other side hooks up to the wing. Imagine. Let me think about this real quick. Sorry. Yeah. The hinge is on the bottom of the wing. The hinge is on the bottom of the wing. So this is. Yep. Actually, this is exactly how it would be actually on the wing. So basically, this hinge is on the bottom of the wing here. These things come up, basically almost touching. Basically like this. This is how this would sit, and the flap would actuate down. So essentially what you're looking at is this is the flap on the right wing, looking from the center out on the right wing. If I remove this wood block and put this back together, basically the way this goes is this will be like this, and it will twist down this way, hinging off of the bottom edge. That's how it works. Pretty simple. Nothing too crazy. Yeah. The only problem I have, like I said, is there is a little bit of twist in this guy, so I got to make sure when I drill this guy on that there is no twist. So anyways, so we have our pilot holes drilled there for our first 3. The only one that's not gonna get a hole through the flap is through the hinge is the outsidemost one. That one is just attached to the rib. So This would go here and get drilled roughly there so we can get rid of the twist. But before I do that, what I want to do now, actually, I probably should do this and then worry about the ribs. But I actually want to drill the ribs first. I want to mount the ribs because that'll make it more rigid, actually. So I've got half the ribs in. I need to drill the other half of the ribs now. All right, let's So what I'm trying to do now is I've got 4 ribs in here. So I want to drill the other half of the ribs onto the skin. That'll make it rigid, but that's okay because once I make it rigid, then I can take the twist out of it and drill the holes through the I can drill the holes through the through where the hinge would go, and then I can then Cleco it all solid, and then once it's solid, then I can take my gaps for my measurements off of the end, and there won't be any twists in it. So that's what we're gonna start doing now. Is drilling this this outer rib. I gotta be careful not to drill my finger. I am trying to line this thing up. Let me move this camera over just a little bit so you can see the area I'm working on. So basically the way this works is I've put a marking down the center line of the rib. I've measured my spacing on the skin, and so now I'm lining up my rib and my my rib with that line so that I can basically drill it as expected. And I am taking pictures for the FAA because I got to take pictures for the FAA to prove that I did at least 51% of the build. Do you got any other questions, Streamer Trash? I'd be happy to answer any of them you have, so. No, this is the first flap that we're building. It's not the first control surface we've built, but it's the first flap we're building. We've done 2 rotovators about 2 years ago, So I kind of have some idea on how to do this stuff from doing that before, but the problem with the flap is it's so much bigger that it's harder to get in and manipulate, you know, the ribs to line things up and stuff. So makes the effort a little bit more difficult. The one trick I do have, the goal is have the fuselage and airplane finished. We have the wings complete, we have the tail complete. Once we finish the control surfaces, which I want to hopefully finish this month, then we just have to do the fuselage. And the goal is to have the airplane in a flyable state roughly end of 2025, but I want to have the airframe complete by the end of this year. So the end of this year we'll have the goal is to have the airframe complete, and then we have to figure out what we're going to do for an engine. I've got a couple options, but I have one in particular that I want to use. So, but it's a little experimental. So, and then once we figure out power plant, that'll probably be the last thing we order. We're gonna spend a lot of money on avionics first and do all the wiring for the avionics. That's gonna be the pricey part. And the wiring for the avionics is gonna take a while too. So that's. The wiring for the avionics is what I'm worried about. What's going to take me, I feel like, the longest of the whole build. We want to put a full IFR panel in it. Not because we intend to fly in like heavy clouds or anything. This plane's just not good for that. But yeah, we're going to take these Clecos off now, since that's fully drilled, so we can get access to that guy. And then we'll put everything back in afterwards before we drill the edge. I just want to have, like I said, a little bit of access, and I won't have access while she's sealed in. Avionics, yes. You have to shield a lot of things. You have to like shield a lot of harnesses and stuff to prevent interference. The interconnects have a crap ton of connections. There's a lot more connections to deal with. That's one of the big differences, is how many connections you have to deal with. But like the actual work itself isn't going to be too much harder than a car stereo. But like, you know, you got to design your power system. You got to design all the switches and fuses. You got to figure out what kind of cable you got to run to ensure that it, you know, not going to melt or anything. There's a lot to do. And it's just a lot of connections, right? Like, there is a lot of connections to do, and that's the biggest challenge, is the number of connections you have to do. Honestly, that's avionics are completely up to the builder. The kit only has all the aluminum parts and the plans for the aluminum work. Pretty much most of the electrical is, unless you go with one of their engine options, and even then, avionics are so variable that that's kind of completely on the owner as far as what they're doing with avionics. So yeah, that's pretty much, you've pretty much hit the nail on the head on that one. That's pretty much all up to the owner and how they want to do it. Or the builder, really, not the owner. Because the builder doesn't have to be the owner. Like, I'll give you an example of something that's completely not in the kit that I did. We installed landing and taxi lights in the wings, and we installed navigation lights. Well, we wired for all of it. We also installed a heated pitot tube. So per plans, there's no electrical in the wings. The original design of this airplane was as a very simple day VFR aircraft, but it's a very capable airframe that's, you know, not too bad. So, okay. So let's go ahead and take this off. So most people do wire it for lighting to fly at night. Um, um, there are people that do put IFR panels in these planes, but it's really, you should not be flying IFR other than flying in the system. You really shouldn't be flying in the weather with this plane. And that's going to be part of my personal minimums for this plane. But the main reason for that is that it's an acrobatic airplane. So the airplane has what's known as neutral stability. It's not positively or negatively stable, it's neutrally stable. So whereas a positively stable aircraft, like think of a Cessna trainer, Cessna or something like that, a positively stable aircraft, what'll happen, if you let go of the controls, it in general will it's because it's stable, it'll put itself in it'll fly straight and level for the most part. Right, you might have a little bit of roll with a heavy wing or something like that, but in general, pitch-wise, the plane will fly straight and level, specifically in pitch, right? And the reason for that is that there's a natural balance between the tail forces and the wing forces. So if you gain airspeed, it starts to oscillate, and the oscillates kind of cancel themselves out, and you end up flying straight and level. Now, and they accomplish by adding a little bit of cantilever and other things in the wings. It depends on really the airfoil shape that you're flying, but that's kind of how that's accomplished for the most part. And so what happens is, for acrobatics, you don't want the plane to be fully stable, because the more stable it is, the harder it is to get it to do things, right? Like spins and rolls and all the kind of fun stuff that people flying acrobatics want to do. So typically, what you see with acrobatic airplanes is usually neutral stability, which means the plane will go where you point it. It's not unstable, right? Like fighter aircraft are unstable, and they need computer control systems to be able to fly them. Otherwise, you wouldn't be able to maintain control. But yeah, there's definitely a little bit of twist in this guy. Put this here. I should probably be able to line this up a little bit better. It's a 12-volt power system. The avionics will support 24, but not all of the avionics, so it will be a 12-volt power system. So technically 14-volt. Typically in aviation, they'll use some lithium ions because they're better power to weight trade-off for like the power density, but not always. Yeah, your most piston aircraft engines are either 12 or 24 volts. Once you get to turboprops, that's when you get to you'll have like a lower power system to get the engine started. But once the engine started, usually they run at like 300 volts AC, I think, or 400 volts AC, something like that. I'm gonna put all the Clecos in this guy for now, just so that it's more stiff while we drill the ends. But all right, we got one rib left to drill. There's one all the way at the end. This one's probably the easiest one though, because this one is the one with the control bolt. And I've got to cut a section out of here, but we'll do that once we have her drilled. But this one has a bolt through it that I can use to twist to get everything lined up. I'm gonna move the tools a little bit closer because I'm tired of walking back and forth. The heated pitot tube is because I do intend to fly at IFR. I live in San Diego, and we get a marine layer, so we get a very thin cloud layer in the early mornings and late at night. So I don't want to. I want to be able to fly in through that cloud layer. So I do intend to put an IFR an IFR system on it, navigator. So I can fly RNAV approaches into the local airports, but that's going to be the limits of my IFR flying. And one of the prerequisites is going to be to have a working autopilot to fly IFR. I mean, obviously, if we got a failure or something, we'll deal with it. But my personal minimums for flying IFR is that the 2-axis autopilot is working. We are putting a 2-axis autopilot in it, so we can fly coupled approaches, so we're not super task saturated in case things are not great for whatever reason, because that's the problem with flying in the weather. But it's not this like I said, this plane is not. You can fly it, you can hand fly it, you know, and probably maintain a you know, but it would be high workload because, like I said, it's neutrally stable. So the last thing you want is super high workload, you know, task saturated and whatnot. So that's why we put a heated pitot tube, so visible moisture. That's basically it. I was gonna put it. I'm putting in the Garmin pitot tube with the AOA, so I might as well put in the might as well make it heated. Doesn't make sense not to. Okay, so now we've got to get the twist out of this. And the way we're gonna get the twist out of this is I actually have lines. I'll show you what I got here. Well, let me take a picture for the FAA here real quick. But this side has a. Okay. So I'll show you how we're gonna take the twist out of this. So we've got our ribs in, basically up to the edge. So it's anytime you have visible and moisture, you can have icing daytime or nighttime. But the last thing you want is for your airspeed to die. So using the flat edge here of this skin, the square edge, I measured out distances and I drew these lines in line with the ribs. And so if you notice, it's actually super bright over there, but there's some lines here, and because this separates, we can get a little bit of twist. And how I can get rid of the twist is by just lining up the lines. Because if I line up all the lines that I drew at equal distances, there should be no twist. So that's what we're going to do. We're going to use our Sharpie lines to drill this with no twist. I mean, the other way to do that is to utilize a jig or something similar, but again, we had to measure to place the ribs anyways, so we've got one in place, and now once we drill this hole right here, the wing will, or sorry, not the wing, but the flap will basically be twist free. But yeah, we have airplane pieces that actually look like airplane pieces, and once the flaps are done, most of the pieces will be a little bit more reasonably sized until we start getting to the fuselage. But and what do you know? All our other lines now line up, which means we got rid of the twist, which is exactly what we wanted. So now we've got to measure out some lines and some holes so that we can drill out this edge. But now that we have it basically formed, we basically have, at this point, a square flap that's rigid. No twists, square flap. And again, this is a right wing, so the way it'll work is the hinge will be at the bottom. Normal attitude, it'll be here, kind of matching the curvature of the wing. And then as we engage flaps, it'll open up. There will be a slot created at the top, which will, make the wing a little less efficient and add some drag. But essentially, you can get up to 40 degrees of flaps, so you can be all the way down here, which is a significant amount of flaps. But normally it'd be like around here, match the curvature of the wing. This airplane basically at 40 degrees of at 30 degrees of flaps, you're basically not generating any additional lift with the flaps. And anything beyond 30, so the 40-degree setting is all drag. You're just adding drag to slow the plane down. But so now let's go back to the plans view. So here's our plans. This is all done, that whole section. We have to still figure out these holes here for the ribs. They have spacing based on this guy up here, but we need the first hole as a reference, so that's why we needed to drill the hinge as a reference. And what we're going to do is we're going to take these off one at a time, mark our markings, drill it, then do the next one, because by keeping these things cleco together at the ends, we minimize the twists by only doing one at a time. And then I'm going to take another FAA picture here, and I'm going to just lay this down here where I can get a nice pretty picture. But so now we'll get our straight edge. We'll get our trusty Sharpie. We'll set the center of our existing hole that's drilled as our reference point. And then we need a mark at 5/8, so 10/16. So right there. We need one at 1 1/4 inches, so right there. 1 7/8. 2.5 inches. Done. So we got our markings there to drill. And what we'll do here is we will put the cleco back on. Now that we have our markings, we can drill that out, cleco it, and kind of go from there, and then keep going down the row. And here you'll see a better example of what I'm doing. And I'll take an FAA picture with this one. So we'll take this cleco off. We use that hole as a reference point, and we set our ruler based on that reference point, and use the already existing line. Use the already existing line that we have drawn there, the whole center line, and then make markings based on our spacings. Like I said, our first is at 5/8, so (10/16). Then we go at 1 1/4. 1 7/8. Holy shit, I think there's a shooting. Give me a second, guys. Let me see what the heck is going on here. I really hope that was fireworks and not a shooting, but that sounded like shooting. But I don't hear any emergency vehicles. I don't see anyone driving by, so hopefully everything's okay. There's not in my neighborhood. It's near my neighborhood though, because it was pretty loud. That that was a little frightening. I heard it through the headsets and everything, and I'm playing music, so that's probably 12, maybe 14 shots. If it was shooting, it was very sporadic, so it was like almost like yeah, that I don't know, cause the music kind of muffled it, the headset muffled it, so I'm not 100% sure if it was gunshots, but it sounded like gunshots. But it wasn't too close because I didn't feel any concussion or anything else, like any relative blasts. But it's been a long time since I've heard like shooting like near me. So that was a little concerning. Basically, the last time I had any firearms going off near me when I wasn't at a range was in Florida when I lived in sunny, gorgeous Florida. But anyhow, you now know how I do those lines that then we're gonna drill out. Let me mark the last two sets of lines, and then we'll proceed from there. If we hear any sirens here shortly, then I'll be worried, but we haven't heard any yet, so I think we're probably okay. What are our distances? 5/8. Looking for 1 1/4. Looking for 1 7/8. And 2 1/2. Oh, did I mark that wrong? I think I marked this wrong. I did mark that wrong. Yeah, I did it at 1/4. Half is down here. Whoopsie, good thing I noticed. But I screwed that up. I marked it at 1/4 instead of a half. Okay. All right, we fixed that. That looks a lot better. Let's do our last set here. It's over here. I think you can actually, let me see if I can get you guys a better view here. There you go. That's the next one we're working on. Hey! Stop it. Five eighths, so 1 1/4. 1 7/8, and 2 1/2. Yeah. All right. Okay, chat. We are ready to drill that bad boy now. Fuck. All right, we got one last set to do here, and then we'll be pretty much done. All right. We are done. For the most part. Drilling this flap. We still have to put the hinge on and take care of that, but that's going to be a separate effort. Let's see. I think we're at a position now where we can put the hinge on. Let's go ahead and do that because we're going to have to drill that hinge. We might as well install the hinge. And we can check the edge clearance on this hinge. Also, once we have it installed here. So now, if we do this, yep, got our 1/16 of an inch. Not a lot, it's just a little bit, but we have a straight edge somewhere. We can use a straight edge now and just literally look at our clearance here. That is a 1/16 of an inch, so. We can now take our flap assembly and we can now take our flap assembly and drill out our flap assembly. That's what we got to do now. Now we got to drill out this flap assembly, and then we'll have to up drill, make all the holes bigger, do a bunch of deburring, do a bunch of other stuff. But let me make sure over here on the plant. We just want to look at the plant one more time before I start drilling. Yeah, the square side, the hinge doesn't overlap. The hinge goes all the way up to the last flap, and that's it, and that's what we have. The hinge goes all the way up to the last flap. Goes here on the very far end. We don't have hinge. That's actually perfect. So we're gonna drill this guy off, cut the end off of it, and then we'll be done for tonight. Next week we'll up drill, rivet it, and then probably start putting the other flap together. That'll probably be the goal for next week, but I do want to finish drilling this flap and cutting the end off of it because I have to cut a part of the skin off. So let's go ahead and take care of that, and then we'll call it a night. So we got probably about another 20-30 minutes of work, maybe. We'll see. We'll see how long this goes. I do want to Cleco this as I go, just so we have better tension as we drill across the board. So what we'll do is we'll Cleco as we go. Cleco one, draw our next one, keep going. So Streamer Trash, do you fly or are you just interested by the project? I'm gonna assume you just think the project is cool, but you know, gotta ask. Oh, and then if you're asking me why I'm keeping this piece of hinge attached, it's because when you drill hinges like this, if you don't keep the hinge attached, they tend to not to bind basically. So what you want to do is as you drill holes, you want to move the hinge around so that it doesn't bind basically. If you were to drill the hinge, you could put a slight twist on it without noticing it. Having the pin through it kind of helps eliminate. It doesn't completely get rid of it, but it makes it a little bit better. So you're less likely to run into binding. But that's kind of where we're at. We're almost done with this flap assembly. I mean, we're done with the basically putting together the flap. We're not done with building the flap, right? So we've got the ribs all placed, everything pilot drilled. We're final pilot drilling the hinge. So the hard part of building this flap is done. You know, we got it square. We got all the ribs installed. We got our spacing on our hinge here. So we got our 1/16 spacing off of the radius of the flap. So the rest of it now is just assembly, basically. You up drill, you deburr, you put in a bunch of rivets. Or sorry, you up drill, you disassemble, you deburr, you reassemble, and then you put in a bunch of rivets. Again, just making sure this moves. It can have a, you know. So, yeah, we've got a flap, chat. We've got a flap. Next week, hopefully, like I said, we'll finish assembly on this one, and then we'll build the other one, and then we'll be then moving on. Then we'll be building the. From there, we're gonna transition to building the ailerons. I feel like I haven't looked at the plans for the ailerons yet, but I think they may be slightly more involved than the flaps. Maybe not. They are smaller, so they might not be. But they do have to be balanced, whereas the flaps don't. The ailerons need to be balanced so that when you hook them up to the bell cranks and stuff, they don't impart any unintended control forces. Because they have to go both positive and negative, there's a little bit more criticality on the ailerons and the flaps. The flaps, as long as you build them square, they're going to be in fixed settings, so it's not really there's not really a lot of concern as far as the flaps. They're pretty straightforward. The ailerons, like I said, you put a counterweight in the ailerons. You're going to hook up the bell crank to the ailerons. You have to balance the ailerons. So it's a little bit more involved, but the initial build will be pretty straightforward because we'll just be doing the control horns. So like we'll have to do the end ribs where the piece is attached to it. So we'll see. We'll have to cut the skin down to size, right? To the proper size, things like that. So it uses push rods, push pull tubes, basically torque tubes for the ailerons. The flap basically has it torque tubes as well, but the flap basically this flap I can show you how the flap actually works. Just give me a second. I've got to flip it over so you can see the other side of it. So obviously we've already talked about how it rotates off of this hinge. Basically what happens is there is a giant torque tube that spans left to right, or the flap actuation tube that spans left to right across the entire fuselage to 42 inches. So it's a long bar that has end pieces, and then those end pieces attached to a link, and that link passes through the airframe, and right on this end right here, on the you see the control horn, this plate right here, this bolt attaches to that end link, and then that end link hangs down here, and then the tube basically rotates and pulls this down and pulls this into position. So we have to actually cut off a big portion of this bottom half here to get enough space to actuate, but the top will stay smooth. And this has an angle to follow the curvature of the fuselage. But let me flip this back over. But yeah, that's how that would work. And we didn't build last week because of rain and I needed a microstop, and we had to redo those drive plates because we made it didn't call tight fit on the bolts, and so we made the bolts we basically just fit the bolts with nut plates behind them, and because there was nut plates, we oversized the hole because typically that's what you do in nut plates, unless it's a tight fit, right? Unless it calls for a tight fit. So uh, we actually needed it to be a tight fit, but it wasn't called out in the plans. But I thought about it from an engineering perspective, and it didn't make sense to me that that bolt would be so loose. So I reached out to the factory, and they confirmed my suspicions, and so we ordered new parts, and we had to redo those parts. But you know, in the grand scheme of things, I'm glad I caught it. I'm sure a DAR probably would have been like, hey, you know, well, you would hope a DAR would be like, hey, this doesn't look good. But it could have potentially led to a flap failure. I do intend to put stops on the flaps. So because I intend to put stops on the flaps, it probably wouldn't have hurt the wing. But the last thing you want is a control surface, you know, flapping around. That's not ideal for obvious reasons. And it's, you know, it's better than the aileron, but, you know, still. They should probably call that out in the plans, but what do I know, right? But yeah, we're... I mean, it's definitely more efficient. At least from a flying perspective, it's more efficient. Anytime you go VTOL, it's always a trade-off. There is a glider version of this airframe that they've adapted to use a Zero motorcycle engine to make it electric, but it is a glider, so that is, you know, a consideration, right? The wing generates a lot more lift, so you don't need as much power, and you don't need sustained power because it's a glider. It's a motor glider, but it's a glider. I am not planning to fly this airplane off airport. If I wanted to do that, I'd probably build a Cub, to be honest with you. Maybe that's something I'll do, maybe not, I don't know. But no, the intent is to mostly use it in airports, and the long-term goal is literally what I want to do is I get 3-day weekends like about once or twice a month. So I want to basically once a month. Long term, the goal is once a month, take the airplane out, fly to a new city or town that, you know, has a couple airports, document the airports, the runways, the approaches, and then document what there is to do in the city. So do a bunch of filming, and then from there, generate a couple of YouTube videos I could release throughout the edit and release throughout the month, and the next month do it all over again, and just visit, you know, a bunch of different cities and states across the U.S. You know, maybe we do some international travel too, but you know, baby steps. The U.S. is already pretty freaking huge, anyways. That's you know, the long-term flying plan. Gee, I gotta check what the weather's like tomorrow because I want to go flying tomorrow. But yeah, I mean, I already take at least like one big flying trip a year. Uh, I do want to do a longer cross country out to Sedona this month. I need to do a couple longer cross countries for my my instrument. So I want to fly out to Sedona. Sedona has a very interesting airport on a plateau. Really pretty. I've been to Sedona before though, so I may go somewhere else. I've been to the Grand Canyon. I've been to Sedona, Vegas. I might fly out to San Francisco. I've been flying in San Francisco, but I've never actually flown myself to San Francisco. So that might be another trip we do sometime here towards the end of the year. We'll see. All right, I'm going to move everything just a little bit closer to the end because we're on the last section of this hinge. And the hinge is still moving good. It's not super loose, but it doesn't have any obvious grabbing, so everything's working. Everything's going to plan. Yeah, I would keep building tonight, like if it was and finish this tonight. But it's almost midnight and the drilling makes a lot of noise for the neighbors. So, like I said, I want to finish this assembly and then next week we'll do all the up drilling, do the deburring, and then do the riveting, and then hopefully start on the next on the left flap. But we'll see how it goes. So once we're done drilling this, oh, absolutely. Canada is definitely accessible with this in the summer. I wouldn't go there in the winter, but Canada is definitely accessible with this. In fact, there are several of these airplanes actually flying in Canada. Not a lot, but there's a handful flying in Canada. The Canada is easily accessible. Mexico is easily accessible. Maybe I'll go visit Flight Chops up in I actually don't know where the Canadian spot is, but we're down to about 10 holes, chat. Yeah, so we'll be done with drilling once this hinge is drilled, and then we'll cut out the section, and then we'll be done for the night. Because cutting out the section isn't going to make noise, so that's a nice Nice thing about that is where we cut out, it won't make noise. And if you're wondering why I'm alternating these clecos constantly, is because I want to keep as much pull on the hinge to the skin as I can as we walk down, because the skin behind it really has nothing pushing it. There's no ribs in here, so when I drill, right, the skin wants to pull away. So by keeping the cleco in there, it keeps the skin tight and keeps the holes from getting elongated on the back skin. But I mean, these are pilot holes anyway, so it's not a huge deal. When we drill it when we upsize it, we'll upsize it alternating every other cleco, so to minimize any kind of a warping of the hole or anything like that. So. We could actually test mount this. Oh no, we can't, because I forgot these are clecoed in, so we can't actually test mount this. But once it's riveted, we could mount it if we wanted to. We probably won't, but because it'll just flap around, and we don't want that. But almost done. We've got 2 more holes, chat. And this guy is still moving, so we're good there. Yeah, the only thing, so it'll be registered in the US. It'll be a US registered plane, so nothing prevents me from flying into Canada. There are some slightly different rules for what you need to be equipped with to fly IFR in Canada. The Canadian Transport Canada requirements for IFR are a little bit different. But you can easily fly Dave VFR, no problem. You just have to familiarize yourself with the differences in rules in Canada. So, all right. Put in one more cleco and we're basically done drilling for the day. Yes, actually one of my coworkers built an earlier version of this plane, took it to Alaska. You have limited airstrips in Alaska, but he had a tail wheel that he put big tires on it. But you can't put very large tires on this plane, so it's not the best option for off-airport operations, but you could definitely go to Alaska. That's actually on my bucket list of things I want to do. So now let's think about this. I've got to think about where I need to cut this guy out. So we've got here's what it looks like. All right. We do this. That's basically our guy right here. Okay. And then we rotate this way. This is up that way. So we need to cut the bottom half of this. So if we rotate this down this way, what we need to cut off is right here. This portion here. Now there is obviously measurements for what we're going to cut off, so we need to identify those. But that's where we're going to make our cut. We're going to make our cut on this half here. And basically we're going to cut from 1/2 inch from the end of the hinge. 1/2 inch from end of the hinge. So these hinge joints are actually exactly 1/2 inch. So I can actually use this other piece of hinge. Let me see if you can see. So yeah, here we go. You can see. So this hinge here, basically each of these notches is 1/2 inch, and the end of the hinge is there. We need 1/2 inch, so we can actually use the hinge itself to mark. So that's where our mark is going to be. And then the other thing we need to go down. We look at our plans down here. Our notch is going to be 1/2 inch and 4 9/16 down. So we're gonna grab our square here. I need 16ths, right? 4 and 9/16 is what I said. Is that what I said? Let me look that up again. Sorry. Chat. 4 and 9/16. Yep. So we'll line this up with our mark, and then we'll go 4 and 9/16. So our mark needs to be right there. And what we'll do is we'll take our square off, double check our measurements here. 1, 2, 3, 4, 5, 6, 7, 8, 9/16. That's what we want. So that mark is perfect. And we'll get our other Sharpie because our other Sharpie has a finer point. I don't know where I left our other Sharpie, but I put it somewhere. It's on the floor behind me. Our other Sharpie right here. We'll use our straight edge again. We'll use our square actually, because here we go. Not a big chunk, but you know, it is, you know, still a chunk that we got to cut out of it. So and the way we'll do that is, yes, but I don't want to be flying to Russia. And South America, yes, but South America gets a little more complicated for flying and stuff. Uh-oh. I can't get the pin out. Let's get a pair of pliers here real quick. Just... There you go. All right. Alright, there's our notch. Okay, there's our notch cut out to give clearance for the control horn. So basically, like I said, that link is gonna stick in here and then grab here, so. Oh, actually. Actually, I might have to cut out a little bit more out of this because it wants. I misread. It wants me to cut out more actually. Basically, the bottom half should stick out about 1/2 inch. Which. Yeah, this guy's supposed to be kind of flush, so. I hope I cut the right side of this skin off. You think about this real quick, chat. Hopefully I didn't screw this up. So this looks like this. We rotate this way. The bolt is at the top. We rotate this way. We're looking at it like we're looking at it. Essentially this overhangs 1/2 inch over that. Yep, alright. So, yeah, we do gotta take a little bit more off of that, but. I definitely need to cut a little bit more off of this, but we will do that. We will do that. Yeah, they want it to go flush to here, so. So that's what we'll do. We'll mark the snip so that we know to where we need to snip. So we'll basically just cut it now up to where we need to cut it and do the same thing over here. I gotta think about how I'm gonna cut the rest of that out, chat. It should be, basically, I should be cutting flush with this guy. I think when we disassemble, we'll cut that section off. We'll cut the whole. There's not even a rivet here, so it really doesn't matter about this. We'll leave this flap hanging, overhanging here. But yeah, and the cutout is only on the bottom side, so. But it should basically be flush against this guy, so. I'll have to disassemble everything to actually cut that. I can probably do it now, but I don't want to disassemble everything. Because we still have to updraw and do a bunch of stuff, and I can cut that after the fact. It's not a hurry. I can I'll grab it with these snips and just cut right across all the way down to there. Will be good, and then we'll have to file it down a little bit, but not a huge deal. That's what we'll do. We'll cut that whole section off, file it down, and we'll be good to go. So that'll be on the things to do next week. We're not gonna updraw this anymore. We're pretty much done building for the night, chat. We will be back next. Actually, I may not be building next Saturday because I have people in town. So we might be off for 2 weeks, but maybe I will build. I don't know. We'll see how my visitor is feeling. No. We snip it and then we file it. There's no need to grind it away. This is super thin. I just don't want to disassemble everything. I mean, I could, if I disassemble this whole section and take out that rib, I can get at it. You know what? Let's do it. Screw it. Let's just do it. It's really not that much. We can reassemble it fairly quickly anyways. Let's just do it. Let's get her done. Let's get her done. I just gotta take off enough where I can separate that. Hopefully, we'll see if this is enough. If not, we'll have to fully disassemble it. But I'm hoping I don't have to fully disassemble. Just take off this corner. But yeah, there's no need to grind it away. We cut it, and then we'll file it smooth. Should be good to go. Can we lift this up? Yeah, perfect. That's all we need. There. So let me flip this over so I have better access. We're going to switch the camera, and we're going to work over here. Yep, that's roughly flush. That's actually perfect. All right. Now we can reassemble. We'll file before we reassemble though. Just use a file and just smooth the edge over. We're gonna deburr all this anyways, but while we're here, might as well just take the edge off so we don't cut ourselves. I don't like sharp corners, so I'm gonna just round this edge here to take the potential to cut us and hurt us away. Something I like doing, getting rid of sharp edges, sharp corners. Not everyone dresses their corners, but I do, because I've cut myself too much working on cars and other things to make the same mistake on airplanes. And she's done. So let's look at our cut now, chat. So we'll flip this over so you guys have a better view. And there's our notch right there. There's our notch right there. And so like I said, a control link will come out from here, and then it has plenty of space there. We keep the front edge so it seals correctly. And we are pretty much good to go. We're going to reassemble everything, and next week, we will up drill this. Well, 2 weeks. Maybe next week, well, most likely 2 weeks. We will up drill this and take care of everything we need to do on this this bad boy. So, but our notch is cut. Like I said, we do have to do a little bit more cleanup, and we will do that when the skin is off. When we go to deburr. All right. We're going to put our hinge back on and then call it a day. And again, the reason we're putting this hinge back on is because when we go to up drill, we want this to actually work. We don't want any binding. So, and the way this is going to work is this is going to go this way. Actually, actually, she doesn't take. There we go. Did I do this backwards? Oh no, right. These guys wouldn't be here. That's what it is. So yeah, that's how this hinge would fit. So hinge still hinges. So we're good, chat. All right, guys. Thank you for watching. I'm gonna clean up here, so there's no point in keeping you guys around while I clean up. So I'm gonna let you guys go. Tomorrow we'll be doing Pacific Drive at night. We're gonna be doing our NASCAR B-car race in the morning, with a break during lunch. For me to meal prep and take care of some stuff I have to take care of for the week. But that's gonna be the plan. So we'll be doing Pacific Drive tomorrow. Monday, our BG3 group should be back together. And then Tuesday, we'll probably be hell diving. We might do Truck Tuesday. We'll probably do Truck Tuesday, but we might do some hell diving as well. So we'll probably do, I don't know, maybe some truck races. We'll see. We'll see. I'm not sure yet. Anyways, have a good night. Thank you for watching. Give me a follow, like, subscribe, do all the fun stuff. Follow me on the socials. And this is our Saturday night stream every night. We build airplanes. So thank you for watching and take care. Have a good night, everyone.